Ladies and gentlemen, our next DevOps expert is a senior technical sales professional with 20 plus years of experience working with enterprise customers and frontline sales and customer success experience. His current focus is to drive adoption of VSN along with CI/CD automation, AI ops, and NLP-based solution. In a while, he'll be sharing his intriguing thoughts on baking security in the value stream and delivering secure apps. Ladies and gentlemen, allow me to hand over the strings of the next session to Mr. Manav Tyagi, the Technical Account Director, APAC region at digital.ai. Coming to your screens right now.
Welcome you all to this session, and I hope you all and your family members are staying safe in current situation of COVID-19. My name is Manav Tyagi. I'm part of the sales organization in digital.ai in APAC region. I handle the technical side of the coin. And as my role say that I love to help my customers technically. I'm in the software industry for almost 20 years now. Started my career as embedded software developer and moved into different roles throughout my journey so far. We all have seen the way the software kind of getting developed, process and technologies getting matured, like waterfall to agile project management, manual to automations. So we are kind of going through with another such change. And I would say that we are in the process of realignment of what we were doing in the past, but more silos way. All of this for sure is to help our customers, your customers or our customers. And I've said that this change is becoming like more relevant in the current situation because the whole world is going through an organization to adopting digitizations on big way to serve their customers, right? Whether it's going to be B2B or B2C, whatever they are, but they want the security and reliability now because of the situation, and most of the people are remote connecting to applications there. So in my session, I'm trying to touch upon the few things that how we are moving on. So let's begin with a small clip, and you will find it. I hope you will find it more quite relevant to the rest of the session that I'm planning to present out there. You can read through it. It's a very, very interesting clip, and I liked it very well. I also mentioned the source, the source of this clip that I picked up in my slide down below. You can pretty much go there. You can find many such clips out there. If you read through it, it's quite a simple one. There are two guys in the clip there. One is an employee, which is a pilot, and there's another guy who say that I'm the co-pilot, but he's kind of a crazy villain, trying to do something which with the security stuff. So let's play with that and see what it looks like.
Captain Dale, is everything okay?
I'm afraid Captain Dale had to bail. I'm your new co-pilot, and I always come to work with a smile. You should be terrified.
Why?
Because I will be taking over the city. What?
Batman will stop you? He always stops you.
No, he doesn't. Well, tonight is going to be different. Your city is under attack by Gotham's greatest criminal minds, including the Riddler, Scarecrow, Pizza Delivery, Bane, hello, Two-Face. We need that door open, baby.
So I think the clip that I just played is quite relevant. What we are talking today, and I'm sure it's in the context. So what exactly? So what is the problem? And let's set the context for a discussion in more in the slides down there. So what you see on the screen is, I'm sure you've probably been hearing all the time in the news in the context of security incidents, and you see that there's just a handful of these, right? There's just few of them, right? That's just listed out for our understanding point of view. But there are such incidents happening on a daily basis, and maybe more every day. At the end of the day, they cost to customers, the countries, the individuals. And for this reason, that's the customers or your customer or our customer are worried about it. And see how they can keep their business safe, their infrastructure safe. So end of the day, what's the question here is how we can help our customers and make them more secure. Basically, think of it like if they can sleep well without any worry about this problem with the security there. So, and the biggest point is there that they should be in a situation, or they should be in a relaxed way that they will not be the headline the next day in the morning, right? But to make that happen, it requires a lot of efforts and a whole lot of activities in designing and building the software, right? So definitely not every breach is in the similar, but in a very broad way, if each of them something to do with an application, right? The application that we use on a daily basis. So, so we can broadly say that they belong to one category, and that is an application security, right? So someone compromising the applications, getting the data, modifying the business logic in the application. So, the idea is how we can build application more secure, helping our customer in the space of digital transformations, which is like very critical part of the business because, and as they are critical, so they are definitely the vulnerable for all these attacks, right? And if you look at the Forrester recent survey around what are the top priorities for any IT leader in the organization, definitely the digital transformation is a very big one because everybody likes to be on a digital transformation, taken a big way and serve their customer. But the second next of that is basically the cybersecurity, right? And the company need to enable their customer, right, to make their self-service, but they want a security to be on the top of priority as well because they want their customer to be secure enough to serve when they serve it, right? So and the security team is just not like some sort of compliance or what kind of old days of security mechanism, just like a firewall or something. It's gone beyond to that. It's like, and one of the challenges, like the teams are working on the product developments and all those things, they're aligned. They're not coordinating. So there's a lack of coordination, collaborations. That makes things more complicated, right? So there are a few other priority items in the list, but I think the top two is quite relevant to in the world that we are living as of today, and where our customers are trying to get into the next level of things, right? So let's see. Do we know, or do you know where your app is? So traditionally, if you look at the cybersecurity approach, if you look at in my slide there, the companies are traditionally been protecting an application as an outside in, right? And focused on the perimeters inwards, like intrusion product prevention, the firewall, the enable filtering, and managed antiviruses. But it has actually gone beyond to that. It's leaving the high value enterprise applications. Think of the bank applications running on your mobile and how it could be painful for loss to the individuals, organizations, if someone go and hack an application which is running on your mobile app, on your mobile phone, right? So the way it has been getting in and the way it is apps are getting in risk level are based totally have changed, and compromising the infrastructure level in the enterprises is again very at a risk in a situation where the hackers can go inside the application's infrastructures and do something maliciously and what they like to get data out from there, right? So a few things like IP thefts and application tampering, the key and sensitive data thefts, and all these are part of that, right? And this is a survey that 84% of cyber attacks happening at the application layer, right? So some way it is linked to the top level of the layer of your application or apps which is running in there, and some way it is getting inside from there to your core of the application. So what we're going to talk, and what is my title of my presentation, the big security. I'll see what it is, but it's more contextually to the a term that is a very prominently been coined in the industry now. It's called DevSecOps, right? So what it actually is. So what are the drivers for it? Like create a security as a code. That's something as a code culture. So it means like it's a driving factor is that's the culture has to be the secured in terms of making the code changes or building the new code. The actions are required to promote this cross-skilling. When I say cross-skilling, that it is not the security no more a job of one person or one scat, and that's what probably would have seen in my video as well when it's promoted. Someone will take care of that if there's a breach, right? And definitely the outcome is the security is for everyone's responsibility, right? That's what we want. I try to replicate the whole situation, the DevSecOps, in a very simplest way, and that's what I drive. I drive this diagram by hand on the piece of paper and took a picture on that, right? So what it actually, the traditionally, and this is what I mentioned in my presentation also, we have learned the software to getting built out in a long way, and we came all the way from, waterfall to agile. So think of it, the requirement phase, design phase, implementation phase, testing, and maintenance phase. And if you drive the diagram, on the left-hand side is the development and the right side is the operations, and you connect these two one, right? There are certain points that we can come back and see that how the feedbacks and how the release are happening. But look at the first development. We traditionally start with the planning, right? And this is what the demand in the market when we say the DevSecOps is that something you codify, you plan something well ahead. When you plan something for your application architecture level, you should plan about the security as well at the level of how you want to secure your block and then applications, or how you want to secure your architecture of your application, which module is secure enough, right? This is something that needs to be planned. Once it get in code and build, and then move out to a testing. So this is one of the change that we have seen. And it moved to after the build and the testing is done, the phase start with operations, where it used to be in a separations between the dev and ops earlier, but now it's called DevOps, right? Where the application lined up and get started with that, like, for example, like configure your environment where the application is going to run and deployment on the target environment. So it's something deployment automations right there. And once the application deployed, then you have to get into an operation phase where the application is actually running. I will touch upon each of the points somewhere where the security breach are happening and where the things are happening as of today. And then after that, you get into a monitoring state where you really monitor applications, how it's behaving, right? So in nutshell, this is our overall process that we've currently been doing and following it up. But when we say the security in phases, let's see what we are doing there. So for example, if you are in the build development side and a build is happening, so build phase, what are the security you can bake into there? There could be a pre-build phase, maybe just before the build gets started, or maybe during the build phase, right? So predominantly, there are two categories of the vulnerability that you can think of at this stage. One is a non-vulnerability. When I say it is something relevant to a vulnerability in an open source library. So think of if your application which you are building is using something which is an open source community or maybe something like Apache, right? So Apache has some figured out in a vulnerability in a particular version of a library, and you are using that library and you have not updated that library somehow. So that is a one breach, and that is something we know. If we go and update it, that's been taken care of, right? Another one is an unknown vulnerability, where we actually have to be find out within the code when you write it, right? So it can be done either static analysis or could be a dynamic analysis. When we say static, there's more of a static analysis security tool that you apply, I would say it's a very robust way of doing it. But the challenge over here, someone has to monitor things, and someone has to go and manually think what are where the breach is actually. And the second one is more automation process, where actually you apply the tool sets which are on a dynamically analyze the situation, analyze the security threats, testing on your applications. So predominantly, these two are things which are unknown vulnerability and a known vulnerability that we look around for a build phase, right? In terms of when application is running in your application environment, in fact, if it is a deployment phase, technology like Kubernetes and all this, well in demand and people are using heavily in there, but it has its own mechanism for making the security app to be deployed securely over there. In a phase of operations, the technologies where things like intrusion detection systems, right, IDS, can be implemented. Like it's more of like on a network layer, right? Then the runtime application self-protection. This is something very important, and I would have a couple of more slides in my presentation where we talk a little bit more in deep on that side, how it helps and what is how we can implement that. And the third one is in that particular case, it's called web application firewall. Can we build within an application? When can we bake something in an application itself, where we really act like a firewall to not to get somebody from unknown domain or unknown IP to get in our applications, right? In the stage of monitoring, one of the things more we do normally is like monitor the performance and something like log analysis, right? The tools who can really some kind of log analysis on that space and get some idea what could be the possibility someone is touching an application maliciously or they are doing something wrong with an application. So this is actually very simplest way I would say that the DevSec operations are connecting and how important they are and how it can be implemented in a very, in a pipeline way. I would say that DevSecOps is a step of the pipeline and where we are embedding the security in part of the development and operation. So if you like to achieve the higher agility and the value through your value stream management system, and this is what my topic as well. So if you look at there are 4 different boxes that you see on the screen, right? DevOps is definitely provide more value, but not on much on a agility side. But in terms of you move on slowly towards the right top corner, and the VSM which gives really the value stream with business, with security, with operations, and everything together, right? And this is where the real positioning of our customers, and they're trying to get to that level slowly out there. And this is what the objective of the business nowadays were. If you remember my conversation, I said as we move on, if you are in a build phase or if you are pre-build phase, then we move. We should embed we bake some security piece in there. So that is something we call, if we shift left, it definitely saves the cost and time for us, right? Because that makes the integration of your security piece in your application development cycle in a very early stage there. So this diagram can get you an idea about it. Even if you start with the stage of your planning, and when you're making the architecture planning for application, if you think of your security at that point there, that is quite good in terms of, because you are already been taken care or maybe already have an idea what's going to be the potential threat to your application when it gets into the real environment and getting deployed and people start using it, right? So that's a very important piece in the whole whole pipeline when you plan that as part of your process, right? This slide makes me crazy, right? If you look at this slide, the picture is there, they're small. I don't know whether you can read all the logos out there, but we have these number of companies or open source products and applications pre-exist in the market, right? But still we have those headlines coming up on a daily basis. And we have to think why. Why, despite of having these number of applications and everything, we are having those headlines coming every day. And this is one of the reasons is that we are not baking the security early in the stage of the applications. We are keeping most of the time things on a very silos way. They are not part of a value stream pipeline as of today. There has to be. And that's what the people are trying to get into there. And this is where our your customers are getting inside in there. And we have to educate and we have to implement solutions with their pipeline and get them on board in this processes. People are really doing good job on that side, and that's what we have seen. So many companies are getting up on this space in the cybersecurity, and that's where the Forrester research has get the second number in a priority for the IT executives there, right? And this is just an example. I took it from the internet. I like that picture. It actually get you the understanding the different phases where you can bake your security in a whole pipeline, and what you want to do it, and what tool set you want to use it. They are pretty much. I think this picture can get you an idea what things can be baked in. Tools are available for those things. Okay. With this, let's get bit and deep in their side so that gets more idea about it. What we're talking about. We look things. So how do hackers hack? Right? People. You already are aware about it. The hackers are everywhere and they try to get something. I'm not saying that they're all good practice and the bad practices, but sometimes people do it. And the some of the organizations, they try to get their application being protected. So sometimes they give a challenge as well to try to hack an applications. But end of the day, what the security explained is software is light of kind of it to me is, I think it could be a different way for understanding for others, but for me it's like software is a set of readable instruction for a computer to understand, right? And if a computer can understand, so a human can understand, because humans only build a computer, right? So that's instruction written by human, which computer can understand, so human can definitely understand. So think of the scenario when you write an application code, which is being executed an application on a computer. Why cannot hackers go and read that statement or understand the statement from there, or understand your programming statement there, right? And if a human understands, then definitely the hacker can understand. If I as a developer can understand, the hackers can also understand that, right? So how it happens? So one of the first and foremost things that the hackers try to get on your application hooked there and try to get reverse engineering application. That means understanding the aspect of the application. So reverse engineering is nothing but application aspect, how that your application is performing or doing it, what it's doing it actually. Try to get reverse out of that and get to the code level, right? To decrypt the encrypted data app on any device, which is a jailbroken device, something which is rooted, where having access to the application. I think you can do that if it is easily can be done. You can easily go to the level of an application code and get those information out there, right? Get the crypto keys, write the code to make the changes. So if you have this one, for example, if you get to disassemble the binary code, you can get the instruction level code, and if you can make the 0 to 1 in the hexa level. So 0 to 1 is a yes to no or no to yes. That means some of the behavior that you like to get through it, you can change that behavior, right? And decompile and get the code available in a hexa and change those values there, and repackage the whole application back into the system and deploy it, right? So the two things are very important: the reverse engineering, and the second one is the tampering. So tampering is basically controlling the logic or controlling the aspect of the application. Where do we can inject the protection in the application layer level, right? There are the application tools, there are technologies already available, and where they can inject the protection in our code base, right? So there is an application and there is a protection on top of that, and you inject that protection, and then your application become like a protected application. The dots that you can see over here, they're nothing but a protections code out within your application, right? So few things, obfuscations, which actually try to get the workflow of your application context, or maybe the alignment of your actual code base, calling the functions and the workflow of how the functions been executed, and they're calling internally to each other. That makes the flow in a very complicated way, so the people or the hacker cannot understand or may get time to really understand to that level of it. The second one is inject the protection. So if you get this red dot out, so if you have the protection applicable or baked in your applications, then if you remove one dot red from here, then the other dot which is aligned to or connected to the previous dot would understand that something has happened to the protection which has been broken out, and then you can take a cause and action on it. Do you want an application to be crashed, or do you want this to be notified to somebody back in the system, right? So there are the protections which can make you, free from risk, is like IP thefts or maybe disabling the license check. Sometimes the people try to get an application installed, even overcome the license check if the application is running, and it happens most of the time if there is a application license is applicable on that application, right? And it actually gets implemented across different platforms. More in deep in the how to back, the code protections of baking the code inside an application. So the post-production build, the example is like, for example, you're targeting an application on a particular processor-based applications or architecture-based applications. So you got a source code and you get some compiler done and you got a binaries, and then you align that protection code on that binary, and then you get your binary as protected out there. So this is one of the way. And it depends on what kind of application you are building and where you're targeting those applications, which level of processor or which process you're targeting those applications. If it is more of a different kind of application like an ARM-based, so inbuilt protection, so basically you get the protection code embedded within before it go to the next level, it's a bit code, right? So you have to get that protection embedded in that level itself here. I explained that obfuscation is how it looks like. So if it is a before applying the security or bake the security within the code base, it may, if you look like the instruction workflow like this, and if you apply the security on that, then it might be end up like this. So if anybody tried to hack an application, they probably had to get more time to really get to the level of understanding of that particular functionality or code or block where they really want to understand from a system, in comparison to if there's no security on that. So one of the important points is how to prevent the reverse engineering. Like, for example, here the couple of things when you apply the right sort of tool and technology in your application when you're building it, and as part of your whole pipeline, you can choose out what exactly that you want to do that and what technology you use. So, for example, like couple of examples, like method renaming. So, for example, if something has been written like that, it can be translated or it could be converted into another string which cannot be easily readable, or something that cannot be identified directly there, right? So if there is a method calling in your source code, which is part of any block of your applications, then you can rename the method name itself. So the hacker may have no idea where that particular function has been called and what the name of that function is there. The another one is like string encryptions, right? So you might have a strings, which is a part of your code base, and there's some sensitive data information are lying there in your code base. So you can think of to encrypt those strings and get in a way which does not make any sense to the hackers or somebody trying to get inside your application, right? But when you said that, it doesn't mean that if everything goes off and the developer who built an application isn't aware about it. The technology has the capacity to build those mapping out, and that mapping would be available to the developer, not to the hacker, right? The another way of looking into that, and maybe it is something I would say that when you apply the security or protection on an applications, and if it is a multi-layer application protection, so the advantage is if someone is going to be breaking out one layer of application of the security, like level 1, level 2, level 3, as you implement the protection at the different levels, it takes time for people to get inside an application to maybe sometime like 1 year, 2 years, 5 years, or maybe 10 years to that level of protection get inside your applications. Keep in mind, anything which is happening in your application, or maybe on somebody is trying to get inside your application, it is just an overnight activity. They would spend the days or years to get on that level because it's not that easy, right? And if you have that kind of protection layer on top of your application when you're building it up, you probably think of it takes 20 years to get hackers to get to the level of your application, really to get some data out from there, right? So it defends in the depth and is provide the code and additional guard layers for the lower level guards, and it definitely makes the implementation every block looks very different. It's not something simple that I can go and check the one. I can break one checks, but still there would be another checks who can monitoring it. So how the software protection routine appears in the normal code. I gave an example in my previous slide before that also, but it is something a very one basic example. Like for example, this is your source code or unprotected app. And then you have a guard spec. Like guard spec is basically the rules or maybe the algorithm that you like to run on your application out there. And they would be aligned to different kind of protection in your applications, which you list out in the guard specs. And the guard specs provide the guard engine insertion in your applications through the library, which translate or which convert your application, which is not readable or understandable for the hackers. And then you get the output from this as your protected app, right? So the guards actually dissolves everything. So it is like you got a software and someone is doing hardening on the software. Software is something easy to get in there. So name is STEM, the name itself says software, right? But if you put a guard on it, you put a hardening into it, you make it hard for somebody to break it, right? And this is what the guard spec dissolve within applications, and it drives it more secure and protected app out of that. So these are all different mechanism, different algorithm that you can apply within the guard specs and apply those protection on your application and get your application secured from there. One other thing in my slide I talked about is that if someone is touching up an application, and I think if you remember my hand note when I was drawing when I had a picture drawn by my hand at the time of operation, when an application is running, you like to apply certain technology on it where we can do self-protection kind of things, right? Your application is running, someone is trying to get a hold on your applications through any means there. What exactly you would like to do after that, right? So you like to do certain analysis around that applications. Someone is trying to get in there, and if something is happening wrong with application, you probably like to break or shut down that application there. So right. So if there is an attack on applications, and there you have a security in place, and you have all the security baked in your application, then probably you would have actions applied on that particular event. When there is an event is happening around that, what action you need to do it. Either you want to repair back the application if something is broken out, or you just simply crash the application, right? So most of the time, the crashing application is the best approach to do it. So how the transforming vulnerability are, or if you look at my hand note, you probably would have seen it. That's how I described at the time of operation of your application, what exactly you can do. And for example, like in-built firewall in applications, or maybe some, the tools which are like, for example, self runtime application, protection applications, where actually take some action on if to happen, right? So if there is an app which is protected, and if there is some code level attacks are happening, or real time threat is coming out there, so there's some sort of alert which can trigger off from the applications, and based on that trigger, either can be traced back in a server somewhere located centrally, or it could be something like just shut down the application or crash the application itself there, right? So you will not get a opportunity hacking or trying to hack your application, really get inside it and do something maliciously, but it just kind of crash it there. So these kind of protections, when you apply in a system, that makes your application quite secure, and especially the scenario where you have commercial transactions like banking applications and medical applications, medical device applications, and all those things. So those are very critical in that scenario, and you don't want to get the hold on these kind of situations. So in the continuity of that, the threat analysis, I was just explaining that's intrusion detection. So something is real-time analytics that you can do it. And there are the tools available which actually drive those threat analytics and intelligently telling the monitoring the application or predicting the intelligence agency what is a potential threat around it, right? So these are certain examples or maybe the pointers for that to understand the intrusion detections in our applications. And by the way, these are going to sometime this gets to be in the real-time analytics, right? So the moment it happens, it triggers back in the system. So what is the key takeaway from the session is actually, and this is what I actually highlighted in the very beginning itself, that security is everyone's responsibility. And I think that is something, an outcome of the whole process that we're trying to get inside there. So change in culture, and it's not behaving like a Lego Batman. Just somebody said, or maybe the developer who was a pilot in the plane and said, someone go and fix that something if something goes wrong, right? So we should not be doing that. So it's everybody's responsibility. We should have a practice secure coding, right? So that's what called shift left is always good to have it. We have started when we started that, the DevOps practices in organizations, we always said shift left. Now is the time when we implementing the DevSecOps, we all say that shift left. So as soon as you plan your application architecture, you plan your application, try to get the security in place. Think about the security, what blocks have to be implemented, what security package, what security top software, what kind of security you want to bake in your application so that it gets high resistance to the vulnerabilities, right? We already have started the journey. A lot of people have gone on automations, but this is one of this area which always been a scope to change and everything to be ramp up there. That's the embrace the automation as much as possible in your whole process. So when you get out of your pipeline, you will have you don't have to go manually intervene in your whole process and get the application with the right set of practices and security aspect on it, right? And the DevSecOps always advocate that security should be built into the product. And this is what I said, that software is a soft by nature. And when you bake security, you make it hard. And that's what is called hardening. So the term called hardening is the right approach to make your application more secure and then make the application deploy in the environment where the customer or where the hackers cannot go and break something out of this in your application. So build an application into product, the security inside your product, rather than apply it when it is a product to be like scanning or something, right, after that. So in that way, so I came to a conclusion to my presentation. And if you look at there, how complicated it is, but it is. And this is what we're trying to drive this whole conversation of DevSecOps going forward.